Hello, and this time we're talking about prime factors. So we hopefully know that factors are numbers that go into. So the factors of 40, if you were just asked for factors, not prime factors, you might say 1 times 40. If you're doing a method that is a systematic method to work them all out, 3 doesn't go. 4 times 10. 5 times 8, 6 doesn't go, 7 doesn't go. Those are the factors of 40. These is a list of all the numbers, and there's 8 of them, which will divide into 40. But when I'm asked for prime factors, what I want is to know the prime numbers that go into 40. And you might say, okay, well, just cross everything out apart from the prime numbers. So 2 and 5, those are the prime factors. And yes, 2 and 5 do go into 40. They are the prime numbers that go into 40, but we also need to know how many of each prime you need to make 40. And by doing this, each whole number, has its own unique prime factorization, but only if you include how many of each prime you have. Okay, so we're going to have a look at that. Just to begin with, if you don't know what a prime number is, it's any number which only has two factors, 1 and itself. So when we're working all these out, we're looking for those numbers, and if you don't know the prime numbers off the top of your head, well then I'll write them out for now, but you certainly should know or be able to sort of think about it and write them down, the first sort of 20 primes or so anyway. So 25, no, 27, 29, 31, 33 divided by 3, 35, obviously not, 37 and 39. Well, I'll leave it like that, so it's unlikely that in our numbers we'll have anything bigger than that. But you can just Google them if you want a big list of prime numbers. So we want to know what prime numbers go into 40 and how many of them. So one way you can do this is by doing a tree diagram, and very similar to before is we're going to split this into two numbers that times up to make 40, and so I'm going to go for something like 2 times 20. And if one of these numbers is a prime number, 2, then we stop there. And in fact, I'm going to circle it, just be like, oh, I found a prime number. And the 20 is not prime, so I'm going to split that again. I'm going to split that into 2 times 10. And 2 is a prime number, so I can circle it, but 10 is not, so I break it apart again. Always by timesing, because these are factors. Yes, when you found 2 and 20 are factors, you say, okay, well, let's break this into more factors. And you keep going, and this is 2 times 5, and this time they're both prime numbers, so we stop there. And the way we write this is we say that 40 equals, and there's 1, 2, 3 2's, so it's 2 cubed, and there's 1 5, so just times by 5. And we write it like this because this makes 40. It's absolutely correct to say that this multiplication, this product, makes 40. And a good way of checking is to type this in. So 2 to the power of 3 times 5, times 5, and you check it, and it gives you 40, and you think, great, I got it right. That is the prime factorization. And you might hear a phrase that's give your answer as a product of prime numbers, or write number 40 as a product of its prime factors in index notation. And so that just means using powers instead of saying 2 times 2 times 2 times 5, grouping those 2's together with a cube to say there's 3 of them times together, and product means writing it out as lots of numbers times together. So same for 65, just be careful. If you say, not sure, but I could say 1 times 65. Well, unfortunately, you're not allowed to do that. It just doesn't achieve anything. Firstly, because you haven't brought the number down, it's still 65. And secondly, 1 isn't a prime factor, so it will sort of sit there sort of like as a factor, but it's not a prime. And if you've been taught in the past that 1 is a prime number because 1 can only be divided by itself, and 1, well, that's, unfortunately, it's not quite the right wording to define a prime number. It's not that it can only be divided by 1 in itself, which is true for 1, but it's the fact that a prime number has exactly 2 factors. So when we looked at 13 before, it had 2 factors, 1 and 13. But 1 and 1 is 1 times 1, and you can't count the same factor twice. It only has 1 factor, 1. So it's not a prime. It doesn't have the 2 factors that we need. So no 1s allowed in this, please. So 65, it divides by 5. So I'm going to say 5, and so 50 is 10. So 55, 60, 65, that's 13. And actually both of those are prime numbers. So we can just say straight away that 65 is 5 times 13. And we would check that on the calculator. 24, we can split into, now you don't have to go straight into prime numbers. If instantly in your head it goes, oh, well that's 4 times 6, that's fine. Neither of them are prime, but that's not a problem. 4 becomes 2 times 2, 6 becomes 2 times 3. Now we have the primes, and so it's going to be that 24 is 2 cubed times 3. 72, so you just have to think of what goes in. It's an even number, so I'm going to start with 2. And if I half that, I'm going to get 36. And I know that 36 is 6 times 6. And 6 is 2 times 3. And that's also 2 times 3 because it's also 6. So there's 1, 2, 3 2's. 72 is 2 cubed. And 2 3's, which is 3 squared. Now for the last one, 90, I'm actually going to show you that your calculator will probably do this for you. Especially if you've got this calculator, then definitely, but most calculators will. They have a button that says fact or something similar to that. And this is yellow, so we're going to have to use the shift to press this. And this is how you do it. You've got to type your number in, so 90, and press equals. And it's got to be equals. It can't be up here. It's got to be this answer here that it will do. And then you press shift and the fact button, and it will tell you that the answer is 2 times 3 squared times 5. Now, unfortunately, if a question asks you to work out the prime factors, it will usually, / almost always say, show the working out, show the method. So you do need to know how to do these trees. If, however, the question isn't about prime factors, it's about something else, but you need to know the prime factors in order to do it, well, then you can just get your calculator to do it and you can just write that down. That's not a problem. But just be careful, because if they are only wanting this, then they will want to see the written method. And just be careful with that fact button. I mean, it should work perfectly well, so we can just test some others. 40 equals shift fact. Excellent. 65 equals shift fact. Perfect. Just try them all whilst we're here, just because I didn't manually, I didn't type this in and check that I was right, so it doesn't hurt to do it like this. 2 cubed times 3, brilliant. 72 equals, and then shift fact, very nice. And then if you just need to know one, let's say 81, if I want to know, sorry, not 81, 89 is what I want to know. If I want to know the prime factors of 89, just do the same thing. 89 equals shift fact. Oh, shift fact. What's happening? It's not doing it this time. Well, it is. It's just that 89 is a prime number. And so the prime factors of 89, well, it's just 89. It's its own prime factors, because there's only one number that goes into 89 other than 1, and 1 isn't a prime number. So if your shift fact button seems not to be working, that's why. But just be careful, because if you put 56 in and press shift fact, then likewise nothing will happen. But that's not a prime number, because you haven't pressed equals. Shift fact. Remember, it will only do it if the number is in the answer here, not up here in the question. Hopefully you can see this nice tree method of how to make generate your prime factors and how to write them as a product of prime numbers with index notation. But if you have any questions, you can put them in the comments. For now, cheerio.